units and measurement, and here it is. Before going to any kind of measurement, we have to understand what is a physical quantity, what is the need of editing, what is the need of measurement. So let us understand what is a physical quantity basically. You can say physical quantity can be any quantity, or you can say any quantity that can be measured. If you say everything in this universe can be measured, yes, we can. I can measure my mass, I can measure my weight. We usually say weight, but actually it is we usually say weight, and but the reality is it is actually a weight, but we measure it in kg, though it is in newton. There is a difference, because our world, the world of physics, and the entire which is in our surrounding is entirely different. So in that case, I can say I can measure my height, I can measure my weight, I can measure the temperature with my skin, with the thermometers, then everything can be measurable. My question came up. All right, can you measure mother's love? Yes, I love my daughter a lot. But is it possible to check whether I love her more, or my husband loves her more, or her grandmother loves her more? Yes, everybody say that me, I am a mother, I must be loving her more than anybody else in the universe. But yes, we can say more or less, but we cannot say how much. We cannot measure love, sorrow, happiness. We cannot measure sadness. We cannot measure loneliness. No, there is no any device that can measure such feelings. So I can say physical quantity is a quantity that can be measured with any kind of physical device. If I can say physical quantities are measurable by an instrument and can be derived, it is also correct. That means if there is a instrument to measure measure a physical quantity, measure a quantity, then it will be a physical quantity. As sorrow, for sorrow there is no any kind of measuring device. Sorrow can't be measured. I can say that I can measure your heartbeat. That's why I can guess if you are scared. But how are you so sure? Rather, it would be possible that I have run up along. I did a running of around 1 hour, or I had did a running of half an hour. That's why my heartbeat is so high. It's not always necessary. It is because of the some kind of fear. It could because of some kind of tension or something else. So, if a quantity can be measured through any kind of device, then it can be called as physical quantity. So I can say physical quantity are measurable by instrument and can be derived. Yes, physical quantity are also expressed in the form of, if they can derive any other quantity, you can say they can form a derived quantity. We will read about it. We will consider about all those things in our next slide. So let's get back to our work only. Physical quantities. It consists of two units. First is numerical value. Second is unit. Now you mean to say, what do you mean by that? Which is a physical quantity and which is a unit? So see, if I say 87.5, what is this? 87.5 is what? Kilogram is what? I can say mass. What are you measuring? I am measuring mass. I am measuring mass. So mass is a physical quantity, because we have said the quantity which can be measured with the instrument is called physical quantity. Yes, mass, height, and we can say luminosity, we can say length, we can say temperature. These things can be measured. So these are the physical quantity. Then 87.5. What is this 87.5? This 87.5 will be considered as numerical value. That's a numerical value, that means number. And this kilogram is its unit. So what is a unit? Difficult question again. All right, we will consider it later on. Come back to our topic again. Now I have measured mass. Now I'm going to measure height. If I talk about height, height is another name of length. So I can say this is also a physical quantity. And 1.4 meter, a numerical value, and meter, that's a unit. Now it is going to be very much confusing what Nishu ma'am wanna say. What is a physical quantity? What is the unit? All right, let's proceed. Physical quantity is actually the magnitude into unit. Whatever is the magnitude, that is 87.5 there, or I can say 11 feet, that is a magnitude. Feet, kilograms, all these things are unit. So if I say physical quantity, what are the examples of physical quantity? I can say length is there, mass is there, time is there, force is there, temperature, and thermodynamic temperature, we used to say that. That is the actual value for it. And then I can say mole. Mole is also a physical quantity. Okay, although it is a fundamental quantity. Okay, so there are many more. And if I say various things like happiness, sorrow, sadness, loneliness, aggression, and tension, do these have any kind of measuring instrument? No, they don't have. So they can't be included in physical quantities. Now talking about usage. What are the usage of these physical quantity? Well, to understand, to determine the magnitude of physical quantity, such kind of physical units are required. Then to compare two similar physical quantities, if I say he is 12 kilogram and he is 12 gram, are they all equal? No, they are not. The unit got changed. To prove physical laws or equations, to prove our physical laws, what are going on, we need the fundamental quantities as well as derived quantity. Firstly, we have to understand physical quantity is a quantity which is used to define the nature of attributes. Okay, so in that case, I have now fundamental quantities. Okay, fundamental quantities and derived quantities. I would like to share both the quantities, both of them, the fundamental as well as derived quantity, both are the part of physical quantity only. So if both of them are the part of physical quantity, then what is the basic difference? See, when we talk of fundamental quantities, I can say those quantities which are independent of all other quantities do not require the help of any other physical quantity for their definition. See, fundamental quantities are divided in two parts. Just like we say, I need 6 colors. We used to have red, green, red, green, yellow, white, black, blue. We just need these 6 shades and we can make numerous shade by that. Suppose I have red color, I have white color, I can frame pink color. If I have that pink, I want to mix some essence of blue color, that will be purple. If I want to add yellow and blue, that will be green. If I want to add red with yellow, it will be orange. Right? So those 6 basic colors are like these fundamental quantities, basic quantities you can say. Okay, so with the help of these basic quantities, we can derive a number of numerous derived quantities. For example, if I took an example of length, if I have a fundamental quantity, length, and that is my base quantity you can say, or a fundamental quantity, something, whatever you would like to think, both are acceptable. Both the names are acceptable for them. So if I want to say it a base quantity, that will also be right. If I want to say fundamental quantity, that will also be correct. So in that case, if I need a derived unit of this length, I can say area. Area is derived from length, and I can say L into B. If I talk about a rectangle, if I talk about a square, it will be L into L. If I talk about any other quadrilateral figure, then again that shape will be count as L into B, something meter square. So in that case, I can say meter square is our derived quantity. See, with the help of length, I have derived a quantity which can give me help to find the parameter, find the measurement of a plane. You can say a 2D figure can be measured with the help of a single fundamental or base unit, that is called length. After that, we can proceed towards the volume also. If I need to find a volume, I need to draw a figure corresponding to it. Consider it as a cube. All right, for an ease, I must say it is 1 meter length. One meter height and 1 meter width. So volume is equals to length into breadth into height, that is L into B into H. So that will be equals to 1 meter cube, and that's all. So I can say I have derived 2 units from length. He said that's it. I can derive many more. See, we will going to proceed. If I pick an example of mass, then considering the mass, that is kilograms. Okay, fundamental quantity for mass is basically fundamental quantity is mass, and its unit is kilogram that we are using. So I can say what is kilogram. Kilogram is basically a mass of a body. Okay, you always go to the market and buy some things in a just like you say, I need 1 kg of potato, I need 1 kg of tomato, I need 1 kg of pomegranate, and something else, whatever you want to buy. You need 1 kg of sugar. You can go and buy the mass of the figure. So, okay, that is the physical quantity, and I want that I can derive a unit. It is not always necessary that only one unit, one fundamental unit can derive other derived quantity. One fundamental quantity and other fundamental quantity can also combine and form a new derived quantity. So here it is, I can say rho, that is density. What is density? For density, we always use mass per unit volume. That means if this is a whole volume, single volume, 1 meter, 1 meter, 1 meter, 1 meter length, 1 meter width, 1 meter height, then that volume, which is unit volume, the mass kept in that particular unit volume, there will be its density. So I can say its unit will be kilogram per meter cube. So here it is. Here you can see all the derived quantities. These are the units of all these square units, I mean say name with that we have given them, and these are the symbols. And I can say physical quantity we all know. So for area I have used length. For volume again I used length. For density I used mass as well as length. I'm marking it mass and length. So that's it. This is all about fundamental quantities and derived quantity. Don't get worried about it, because we will gonna study number of derived quantities afterwards. We will going to discuss them. Now it's the time to understand what are the international SI unit system. But before that, I would like to tell you how these units got developed. So to understand all these things, you have to understand what is a unit. So what is a unit, guys? All the physical quantities that we need to consider. Suppose a physical quantity that is called as length, mass, time, electrical current, temperature, luminous intensity, amount of substance. All these physical quantities need some units, need some name by which we can call them. Because every time it is not possible that we have to mark length, 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 length. No, we just use meter. We can use kilometers. Actually, everybody have derived their own units. They have marked their names. Suppose if we talk about length, you must have heard about foot. See, if a person went to a shop, that is a fabric or clothwear shop, garment shop you can say, or you can say to buy some kind of material, fabric. So he went to some kind of fabric shop and he says, okay, I just need uh, 10 foot, 10 feet, 10 feet of cloth. Then that will be very confusing for a person. He said, okay, I'll keep a foot length for my measurement. I'll bring a foot measurement. That means 1 feet scale for that. And then I'll measure, then I'll let you know. Then you just come back, then I'll give it to you. Okay. He went back. Then another person would come up. He said, okay, I want 4 meters of same fabric. He said, okay. He have the inch tape. He just measured that 1 meter, 2 meter, 3 meter, 4 meter. It's okay. That is 4 meter. You can keep it. Then another person have came up. Hello, I want 2000. That means 2000 centimeter of this particular cloth. He just got confused. He made a calculation. Meter, then convert it into centimeter, and then give it to, and then make the calculation according to it. Then returned it back. Then another person came up. He said, I want 40 inches of same fabric. He is just like he wanna snatch his head. He got too much confused. What to do now? There are innumerable units that are going on. Suppose you went to a shop and you asked the shopkeeper, please give me 2 kg of sugar. It's okay, he will give you. Another person went, he said, I want 4 pound of sugar. How to measure that? The first question came into the any kind of shopkeeper mind. Similarly, this never ends. And as we have told you that the basic law of physics is its unification. So physics follow that particular unification process, and by that they used to pursue, yes, now we can do it like this. हम एक single unit consider करके चलेंगे. And in considering that single unit, it make a fuss of all these things. Then they said, okay, let's find a solution for it. What is the solution? Solution is we have to design a single unit for it. Okay, so with that note, they have started a process. They have started a scenario in which they have designed the units. So guys, these are the seven. These are the 7 internationally accepted units. Now you will say, why are they only selected as SI unit system? Why not others? If we talk about temperature, we use degree Celsius. Though why it is marking on Kelvin? That will also increase our calculation. He said, okay, we cannot. But there was a rule behind it. See guys, basically when we went to any other shop, any shopkeeper in any country, they try to have a single unified scale to measure everything, because it's okay. A person who is a main shopkeeper can give the such kind of calculation, can give such kind of measurements, can borrow number of can buy number of physical quantities, physical measurement instruments to check out if the length, if the mass, if the temperature, if the amount of substance can be present over there in front of you or not. But when we talk about to get a standard unit for it, that will be difficult. So to understand this thing, we have to do some kind of unification. So length, mass, time, electric current, temperature, luminosity, amount of substance, plane angle and solid angle, though they are not included in fundamental unit yet, but yes, people are trying to, people are starting doing that with their own notes. So with that particular note, I would like to end up my lecture.